Alright, we're going to talk about a segment of a circle. A segment of a circle is bound by a segment and the arc that goes with it. So the segment of the circle here is this little area in between the triangle and the edge of the circle. The crust of the pizza, if you will, something like that. So name the chord and the arc that bound the shaded segment. Well, segment AB and arc AB. So they have the same letters, but one is a segment, one is an arc. Describe a method to calculate the area of the segment. Well, let's pretend that this is it. We're going to take this, but what we're going to do is subtract off this. And what's left is our segment. So we're going to take the area of the sector ACB and subtract the area of the triangle ACB. Again, same letters. So let's do it. The triangle there is 90 degrees, it says that. The radius is 8. So if we want to find the area of a sector, it is area of a sector over pi r squared. Our area of a circle equals the measure of the arc over 360. So the area of the sector, we don't know, that's x. Pi r squared, it's pi times 8 squared. Measure of the arc's 90, it's a right angle, over 360. We cross multiply, we get 360x equals 5760 pi. Divide by 360, x equals 16 pi, or 50.3. Find the area of the triangle. It's just 1/2 base times height, which is 1/2 times 8 times 8, because the base and the height are the same thing, they're the radii. So 1/2 of 8 times 8 is 32. So 16 minus 32 pi 16 pi minus 32 centimeters squared, or if we rounded, 18.3 centimeters squared. So again, we found the area of the sector using what we were doing earlier this week. Then we subtracted off the area of a triangle, which is 1/2 base times height. Length of the radius is 10 inches. Calculate the area of the shaded region of circle O. So now we're going to do something different. We're going to look this way and then add on the triangle. So we're going to do the area of the big sector plus the area of the triangle, because that adds up to the shaded area. So again, area of the sector, x, we don't know. The area of the circle, pi r squared, r is 10, so pi 10 squared, equals, well, this is 270, because the whole thing makes up 360, and we already have 90 here. So it's 360 minus 90 gives us the 270 here. So 270 over 360. We cross multiply and solve, and we get that it's 75 pi. So 75 pi plus 1/2 base times height of this triangle, 1/2 times 10, which is 50. So we have 75 pi plus 50 inches squared, or 285.6 inches squared if you want the rounded answer. So again, it's just adding and subtracting things. James covers the entire top of his pizza or pie with whipped cream, but he doesn't like the upper portion of the pie crust where it is thickest. EP and EL are radii of a circle. Measure of EP is 4 inches, so is IE. And the measure of angle PEI is 60 degrees. So what in this situation relates to a sector of a circle? The whole piece of pie is a sector of a circle. We could draw the rest of the circle around it. What in the situation relates to a segment of a circle? The upper crust, this part up here, which James doesn't care for. If each piece of pie is the same size, how many pieces are in the pie? Well, it measures 60 degrees. So 360 divided by 60, we could have 6 pieces that are all have the same measurement, the same central angle. Determine the area to be covered with whipped cream before James removes the upper crust. So we're looking for area of a sector. So again, it's area of a sector, x, over the area of the circle, pi times 4 squared, equals the measure of the arc, 60, over 360. So we cross multiply, we get 960 pi equals 360x, divide by 360, x equals 8 over 3 pi, which is about 8.4 inches squared. Determine the area to be covered with whipped cream on only the upper crust. So what we need to do is find the area of this triangle. We know those are 4, that's 60. So what I did is turn it upside down, drop an altitude, and it splits it in half. So it's a 30, 60, 90 triangle. Hypotenuse is 4, the short side is half of that, 2, and the long side, the long leg, is 2 root 3. So our height is 1/2, our area is 1/2 times the base, 4, times the height, 2 root 3, which gives us 4 root 3. So if we take, we're finding the area of a segment here, so we take the area of the sector and subtract off the triangle, and that's what we're doing. So the area of the sector is 8.4, area of the triangle is 4 root 3, we subtract it, we get 1.47 inches squared. So very little that he's losing. Determine the length of the upper crust. Well, now we're talking about arc length. So this is just 2 pi r, our circumference, and x is going to be our arc length. So it's x over 2 pi r times 60 over 360. Cross multiply, we get 480 pi equals 360x. Divide by 360. So x, or our arc, is 4/3 pi, or 4.2 inches pi, or 4.2 inches.